Um, I would ask you, please, if it's possible, to sit down. We want to start soonish, if possible. People coming in, please sit down, and then we'll be able to start. You know what? While we're waiting, Edwin, please come in and give your announcement now. At least you'll get something, and we'll start the recording the minute. This is Edwin. Edwin has something to tell you.
Edwin De Angel, I know that big interest tonight on AI, and I just wanted to start by. And if you're interested in AI, you're probably interested on how to make money with AI. And we are making a panel on licensing IP on AI. The panel is three weeks from now. It will have attorneys, CEOs, and VCs, and I will have flyers in the back. If you have interest, come talk to me. I am also looking for Python developers on backend for some future projects that we have oncoming. Thank you.
Yeah, we're going to wait a few more minutes. We need technology to start the recording of what we're doing here. So please mingle for a few more minutes, and we'll give you an announcement when we start. Just press the button. Just press the button. Good. Just press it.
I don't know if the sound is connected. I don't know if the sound is connected.
I will. This is their problem if the sound is not connected. Correct?
Yes, sir.
Okay. Sorry for the delays. We're gonna start. We had some technical difficulties. Welcome to the Python meetup. This time we have multiple of our organizers around. So Tipton will be talking in a second. Danny, you probably saw when he came in, and we're happy to be here in Capital Factory. Actually, Capital Factory has been sponsoring us for space for a long time, many years by now. And they wanted to give you a message in form of a video. Hopefully the sound will work. And
Welcome to Capital Factory. We are glad you could join us here at the center of gravity for entrepreneurship in Texas.
We bring together entrepreneurs, developers, and designers across Texas for meetups, classes, co-working, mentorship, events, and our accelerator program.
At Capital Factory's core, we're all about people and making lasting connections.
We meet the best entrepreneurs in Texas and introduce them to their first investors, employees, mentors, and customers.
We hope that you'll join us again and consider becoming a part of our community.
For more information on becoming a member, head over to join.capitalfactory.com.
Thank you.
so beyond the video, this place is actually a good place for entrepreneurs. If you roam around here for a little bit, you will understand why I'm recommending it. So please check out Capital Factory online and come here and talk to the people who actually organize it. So they provided us space for many years. They really support the Python community in many ways, by the way. We also have multiple meetups in the Python meetup. We have the evening of Python coding that that happens in Galvanize every third Tuesday. Every second Wednesday we have the main Python meetup, but now we have another meetup that Tipton, one of our organizers, is setting up, and Tipton is going to talk about it a little bit.
Okay, this is not really an independent meetup. I have made arrangements with the folks at Galvanize to present a practicum course in the development of a blog using Python and SQLite and just a very few packages, a project that I worked on a couple of years ago. And we're going to extend it. It's at the stage that I can use the program because I wrote it. And I'm going to refactor that, or we're going to refactor that into a distributable or almost distributable program that anybody can use by themselves. And they won't have to be a programmer to use it. So this is just a practical course in taking a code base and moving it from a somewhat working piece of stuff into a presentable and working piece of stuff that a non-technical person could use. This is a class that will take place on Monday evenings starting March the 9th and meet every 2 weeks until May the 18th. There's a fair amount of programming to be done to get this to work because the code that I wrote initially is really not all that good. So the registration for the class is at Galvanize. You can go there and look up their courses and you'll be able to find it. You can find a link to the Galvanize location if you go to the APUG website and check it out. I think I'm now third on the list, maybe second on the list now that this meeting's gone. Developing a blog in Python, you can find the Galvanize link and go there and register for the course. Some people have seen the announcement and have put themselves on a waiting list. We don't actually have an APUG waiting list. All of the registration needs to be done through Galvanize. So if you're on the waiting list, please go to Galvanize and sign up for the course. I was told today that 50 people have registered. The maximum size of the class is 100. Again, it starts on March the 9th, meets every other week until May the 18th. You're welcome to come at any time and participate in the class. There's no credit for this. There's no cost for this. It's a free exercise. It just takes some skull sweat and time to work through the process.
One more thing, the registration is through the Eventbrite link that you'll see in the meetup page. So don't click attend and go to the waitlist. This is what Tipton is trying to say. This is okay now for the announcements. We'll come to the main part of our meetup today, and we have two presentations that are related to each other. They will both talk about Kubeflow. One's from a user perspective, which Muhammad El Said is going to go and present first, and later on, Josh Bottom from Richter, who actually the company who is sponsoring the meetup today and involved with the development of Kubeflow. He will present his perspective on Kubeflow, and there will be an announcement of a new version there. But he'll tell you the details. So without much ado, please accept Muhammad. He will give us the first presentation.
Thank you. All right. Perfect. Not perfect. All right, so thanks everyone for coming today. Thanks for all the organizers, sponsors for sponsoring this. Seeing a lot of familiar faces, so it's always good to see everyone again. So today is going to be journey of how painful is deploying machine learning models in production with a lot of constraints, and from going to just deploying it in a Python Flask app into using Airflow, Kubeflow, TensorFlow, Estimator all on top of GCP as a platform. But in order to understand this journey, we need to understand what is the context of it. So my name is Mohammed El Said. I lead a machine learning team at GroupBuy, which is a search engine optimization company based in Toronto. Our mission is to create the world's most relevant and highly converting site experience and maximizing revenue. So GroupBuy was founded by search experts from Oracle and Indica. Actually, we were Google's North America Partner of the Year, and we were on the top 50 startups to watch in 2018. So to understand a little bit before jumping into the details, we kind of need to understand what we offer, right? So we offer mainly 6 offerings, or there are 6 components to getting the whole product. First of all is, of course, data management and ETL processes. We need to process this data that comes in. Remember, it's online data, so it's streaming data coming very high velocity, and there is a huge volume, especially when it comes to the season, Black Friday and Cyber Monday kind of things. So after that, once the data is ingested in the platform, there is data enrichment. So sometimes there are discrepancy in the data, there is missing attributes in the data, the products are not good, maybe sometimes the cookies from the websites are not good. So we need to fix that before doing any other process. The content management system. So we provide our clients a management system to be able to share the media, do any biasing profiles that they need to use, or use any specific attributes for the products. After that, search engine optimization. The queries need to be returned fast. You don't want those 404 errors or runtime errors. Search, navigation, and recommendation. So this is more in the personalization aspect. Given a client from one of our customers, want to make sure that he or she or they have a personalized experience tailored to what they want, and also not biasing it to what they only want, but also looking at the global popularity as well. And after that, just reporting in analytics, making sure everything is working, all the customers are happy, and all the dashboards. Mainly, the machine learning part is in data enrichment, search, navigation, recommendation, some of the pre-sales, proof of concepts for clients. But in the context of today, I'm just going to focus on the search, navigation, recommendation, just because of the constraints. So the cloud platform is, you have data that gets ingested, it gets data enriched, there is a learning system that happens, and it's exposed through a layer that you can, the client just have everything in the cloud. They ping the cloud, everything is connected. There is a headless, serverless server over there. You don't have to worry about anything or any deployment. So the enriched the data comes, the product catalog comes into the data, or the data comes in and it gets ingested, and then you have a user signal from the behavioral data. So people start interacting on their websites, and you have these signals that come in. After that, it gets ingested to the semantic layer, which all the magic happens of personalization recommendation. So the semantic layer will expose all the search as you type, the search, the navigation, the merchandising, recommendation, personalization, and the analytics. And that's all detailed in one layer over there. So as I said, there are multiple aspects of it. What we're going to focus on is the recommendation, which we call as a product as Searchandizer. So it's more focused on the ML, on the personalization, and the recommendation system. So Searchandizer, the main motivation was built to help shoppers show the products, help them understand what is more relevant to them, and that serves as a win-win situation. When the customer wants or finds what he wants without looking for it, it's easier conversion. The customer is happy, the clients are happy, and everyone is happy. Revenue's up. So the idea is more or less to map the behavioral aspect of human going through a website or a shopping experience. So it is a standalone product for us, and the idea of it is just because there is a vast majority of clients from tractor supplies to department stores. You can have anything in the middle. So it really depends on what it is that you're trying to do. And of course, post that, we need to prove that if we go to the customer, hey, we have done some research and we find that there is a new algorithm that we tried and we did test it, and you're going to have a higher conversion on it. So we need to report that with numbers. We need to prove that it's statistically significant, and we need to provide all the statistical data that would help the claim that we're saying. So testing and optimization. So this is a really tricky part, and this is why specifically I kind of chose this product to talk about, is because the deployment of this and the A/B testing, especially when you're doing online predictions. So the problem with this, or the challenge and the fun with it, is when we're doing A/B testing, we're actually optimizing for something in the back end. So you have, let's say, 4 models running in parallel, all the traffic are split. And for some reason, the data engineer aspect of it, something went wrong. So one of the models is just predicting trash, just because the data engineering aspect there's something missing in the middle. So we need to be able to capture that, because we're dealing with revenue and we want to make sure there is no problem. So in that case, we do have an optimization process. It really depends on the client. So we can optimize for the let's say, click-through rate, if they're going to click on that product or no, or the add to cart rate, or the conversion rate, so if they actually buy it or no. So that's a client decision depending on what they want. But the idea is it will lifetime, if one of the models are not performing as well, it will completely divert the traffic from it. So we don't need to spend a whole day and then we have a problem that this much of revenue was lost because a data engineering problem or a model had a bug in it or something. So the optimization process and the deployment of it is really tricky. And with this, you're all talking about live predictions. So you have to have the predictions back within less than 200 milliseconds. Otherwise, we cannot deploy that model. Targeting and triggering, I touched a little bit on it before, but the idea is we want to make sure we're targeting the right products for the right customers. So what happens? One of the problems is someone search for something and they get a null result. One of the problems can be maybe it's a spelling mistake, or they are, one of the things, it's not actually on the website. Sometimes it's actually because it's one of the attributes of the products, but it has nothing to do with the text. So the way we deal with it is we have a post hoc analysis on the number of null searches, and it goes on a PCA to be able to go it down to a lower dimension, understand if there is a specific topics that are getting null searches. So if we're doing that, we go back and we do the data enrichment part. So this is more of an iterative process that helps in the navigation engine at the end of the day. At the end of the day, our goal is increase conversion, and that's defined on the customer. So it's either add to cart or actual orders. So just to sum it up, the optimization, you have the ETL process, you enrich the data, you do search engine optimization. On top of that is the personalization aspect. And with all of that, you can do click boost, you can do navigation intelligently, and that's available as a CMS for the clients. And you've got the smart synonyms, and the recommendation is over there. So before jumping into a little bit more details, just giving or having like a definition of what are different things and being able to separate them so we're talking the same language. So when we're talking like an AI or machine learning frameworks, we're talking about like something like TensorFlow, PyTorch, any Onyx supported. It doesn't have to be Onyx, it can be sklearn, but mostly we're using unstructured data for that. So it can be any of that. Pipeline. So pipeline is not only the ML model, it's from whenever the data is ingested from the clients, transformations happening. We need to normalize data, we need to aggregate data, and then pinging the model, training the model, serving the model, and looping over that again. So that would be something like TFX, Kubeflow, Airflow, you can name it, MLflow as well. And then an AI or machine learning platform. So this is actually a platform that serves upon all of this and being able to manage, retrain, and do all of these things. So you're talking about GCP, AWS, Azure, and so on and so forth. So deep learning and training and hyperparameter tuning. So it's always a big pain waiting for a neural network to train. So we had a problem with, first of all, running on premise and then going on the cloud and being able to manage all of these requests of, oh, we need more GPUs, or we have problem with that. But not only that, it's not about how big is the GPU, but also making sure we're utilizing parallel computing, right? So we're using more than one GPU to do a process if it's possible, just making sure that you had an experimentation. Machine learning has a lot of experimentation. We always have a hypothesis. We say, okay, we think this might help, and this is the aspect, or this is the reasoning for why it might help, but we need to validate, and to validate that, you're running either TensorFlow models or any other models, especially when it's deep learning, it takes a lot of time. And it's not only that, it has a lot of parameters. So when you're doing the hyperparameter tunings, you're just going a lot of time in that. So that's kind of one pain point that we need to focus on. So when we're doing model deployment, so that's the other pain point. So I can create like a Flask app, load my model.h5 if it's a Keras model saved, and then you just define a classify function, you get the text, you send the request, you do the pre-processing, and then you do the predict, and then you dump the request. So pretty easy, not too bad. Problem with that is no consistent API. So every time you're going to have a text model, it is not going to be same as image model. It's not going to be same as structured model. Payloads. If you are on Cyber Monday or Black Friday and you receive 10,000 queries per day, or per second, sorry, then, of course, it's 10,000 queries per second. How are you going to manage the payloads for all of that? Because this is a Python functionality, so it locks up your whatever CPU or GPU you're using for only one instance. How are you going to save models? So how are you going to manage the model versioning? How are you going to have metadata about the versioning of models in that case? Mini batching support, very useful when you're doing prediction, especially online prediction. And another big problem is large models. So if you're talking about you're doing a text classification or something, and you're using, for example, let's see, Universal Sentence Encoder, right? So that's a 3 gigs model. How are you able to deal with that? So all of these are pain points or problems that will or had us move forward to trying to find another solution. So the first solution that came up on the stage was the TF estimator, right? So anyone familiar with TF estimators? Just raise your hand. Perfect. Cool. So TF estimator is just a high-level API, so it encapsulates training, evaluation, prediction, retraining, and exports to serving. So you can either use a pre-made estimator, so you don't have to worry about anything. It's already there, like a DNN classifier or wide and deep. They have a couple of wide and deeps. Or you can create your custom estimator. So a custom estimator means you are creating a custom model. So if you have any fancy things, if you have instance normalizations and you're doing multimodal, you have images coming and then text coming, and then you're putting them in lower dimensional space and then concatenating them and having a lot of fun in there, you can do that in your custom model. So you can either run it locally or on distributed multi-server. So you always want to run it locally first because spinning up the machines takes a little bit of time. So you don't want to wait like 6-7 minutes to spin up the machines and it's like, oh, you've got a typo online, whatever. So you want to make sure it's running locally first, and then after that you can submit the job online. And it just provides a safe distributed training loop, so you can visualize all the training on TensorBoard and handle the exceptions and create checkpoints. But still, that's only the model aspect and how you train it, but how do you make a pipeline of it? So we went with Airflow. So Airflow, anyone familiar with Airflow? Cool. Nice. So you create DAGs, which just functions that ping something to do. So for example, you create a DAG, okay, grab this data, and then after that, run the training job. After that, do prediction. So it's pretty systematic. So, but the problem with it can be a little bit complicated. So for example, this is one of the DAGs for one of the customers, one of 40 something or 30 something. And this is only one DAG for running one job. So you can see it can get a little bit complicated. Everything is dependent on it, so you cannot run anything in the downstream if you have not ran the upstream of it. So how can we solve this, right? So we're back to stock. Yes, we've done a lot of improvements. We're able to train it in a good way. We're able to kind of pipeline it in a way that's working, but still there is kind of bottleneck there. So this is where we got with Kubeflow. So what it helps with Kubeflow that we found it very helpful is it's just a platform for experimentation and especially hyperparameter tuning, because in all of the above, we still haven't pointed or solved the hyperparameter tuning. So it has CADIB, which works with all the hyperparameter tuning. I think Josh is going to talk about that in his presentation. It provides the distributed training. So we said we use TensorFlow estimators, so it actually it works with TensorFlow, so it can serve TensorFlow pipelines. It can serve Onyx models. So if you have PyTorch, I think it does serve sklearn and Seldon Core as well. It has the orchestration of hyperparameter tuning, so it has CADIB. For us, it's a headless deployment for A/B testing because we can just take whatever process we can do and we could implement it on top of Kubeflow. And it's Kubernetes native, so we love it. So this is a diagram of what Kubeflow gives you. So you've got the serving part, which is, I talked a little bit about it. So you can do KF serving, which is the Kubeflow specific serving, or you can do Seldon Core, TensorFlow. There is a lot of options there. So you've got Jupyter notebooks, so you can spin Jupyter notebooks. You can change what type of machine that you have without losing the data and on the spot, and you can kill it. So one of the really cool advantages of Kubeflow is zero scaling. So you can scale it to zero, so you're not paying for anything if you're not working on it. It has all the training operators. It has the workflow building, all the pipelines. It actually is compatible with Airflow. So one of the jobs that we have is an Airflow job and then goes to a Kubeflow after that. And it's compatible with TFX as well. And I guess it's a demo time. So what we have for the demo today is a text-to-hub demo. So this is an available Kubeflow pipeline on AI Hub. Anyone familiar with AI Hub? Cool. So it's a great option. If you don't know it, Google it. It has a lot of already made, sometimes pipelines, sometimes models that you can train or you can use. So you can load BERT with 2 lines of code from AI Hub. So it's pretty helpful. If you're doing ML stuff, have a look at it. So the idea of text classification or understanding text in general, either within classification or embedding, is 2 big problems. First of all, the out-of-word vocabulary. So if you have a word that is not in the vocabulary, which is, let's say the embedding is trained on Wikipedia or Google News or whatever it's trained on, if you have a very specific text data, let's say medical data, it might not be there. And if it's out-of-word vocabulary, it treats it as it not there. The other problem is the spelling mistakes. So the spelling mistakes will cause a problem because it will treat it as an out-of-word vocabulary. So the way that you can come around that is actually take this pre-train, retrain it on your actual text data, and then you have an embedding that takes it to another. So it computes the co-occurrence matrix for the words, and then from the co-occurrence matrix, it goes to the embedding space. So that's a high-level overview of the intent of this demo. Let's see. So what you want to do is you actually want to download this. So you can download it over here, press download. I already have it download, so I'm not going to do that, especially because it's not my laptop. So if you go on Kubeflow, so you can create a Kubeflow service through either We do it through GCP, so it's connected to GCP. So this is what you would see. You would have the pipelines. There is the notebook service. Catab is what we talked about for hyperparameter tuning. And then this is what you have over here. So this tells you the CPU utilization, and it has a lot of interesting stuff. For the purpose of over here, what we're going to do, we already have the pipeline downloaded. So we'll go to pipeline, and you press on upload a file. You choose the file from your local, and then you upload it. I already have it over here, so it's that text to hub. So if you press on it, you have three components to this text to hub. So it's text to COOC, which is co-occurrence matrix. So that creates the co-occurrence matrix, and then from that, the second component goes to the embedding space, and the embedding space put it to a hub. So if you want to run that, you want to over here create a run. So when you create a run, it's going to ask you for a couple of things. First of all, the inputs that it needs for this run to do. For over here, it's asking for a name, so we're going to say test2, because I think we already have test1. For the experiments, for now, we can choose default, which is the default hyperparameters. So number of epochs and the embedding dimension and the co-occurrence size, window size. Over here, you have two other things that you need to look for, which is what is the text file that you are going to retrain the embedding on or the hub on, and what is the output directory path. So over here, if I go to my notebook, sorry, that's a lot of stuff. So I have a surgery manual text. So it's very detailed medical data on operations and how to do operations. It has very interesting words in it you're not gonna find in your everyday dictionary. So what I'm gonna do is, over here I import the I need to specify what is the project I'm working on and what is the bucket I'm working on. And this is the website or the link for this specific text data. So I take it, I download it, I dump it in a GCS bucket, and I echo the GCS location, which is going to be here. So I'm going to copy this, put it in the location over here, and over here, it's asking for the directory. So the directories are going to be this guy over here. And then I'm going to start it. So over here, you're going to see the different runs that you have. So this is kind of like I was playing around, and these are specific runs that we have. But this is test 2 that we've done, and it's not working. Okay, let's see. Exit code 1. Okay, I think I know what's the problem. Let's do this. I probably need to remove all the data. So let's try this again. So go back to the pipelines. Choose your text to hub, create the run. Hopefully it's the last time we try it. And you got any questions so far? Yes.
Just kind of a question about the tooling you're using. So any particular, so you mentioned some nice things about Kubeflow. Is one thing that's implicit in this is, does it integrate nicely with Airflow? Like, does it have a naive one-to-one mapping between an Airflow task and a essentially Docker container running in the background? Or is there a particular reason using that as opposed to some other pipeline tool like Luigi, or I don't know, there's probably 5 other ones that I don't know about.
So you're talking about Airflow with Kubeflow, right?
Yeah, exactly. So I understand why Airflow is good. I understand why Kubeflow is good, but like why? Is there a particular reason you're using those two together, or is it just that both of them are good individually, so use them together, and that's also good.
So for the reason or for context of what we're doing, it works pretty good because Airflow for us is pretty good in data pre-processing. So any transformations, it can speed up like, up to 1,000 machine because it's using data flow in the backend. But that's why the reason that we have it. We already have processes running in Airflow. So we took the nice thing about Airflow, which is parallelizing transformation, and we feed it into Kubeflow.
Right. So we did something similar, but it was with Amazon. So it was sort of Luigi and AWS batch together. And I guess I was wondering, but in that context, any given task actually has to hit the API and say, please run the following Docker task, and here's the image, and here's this and that. I'm just wondering if there's a tighter integration between the two tools you're using than the ones I just mentioned.
It's the talking between them it's been way better. There is always going to be a little bit of playing around, but we do have to export the Docker image to make them work together. But to get your question, I'm not familiar with the ones on AWS that much, but it's not too bad. Like it's not as bad as we thought. So we started that back in let's say end of December, starting these experiments of using Kubeflow. We've got in around a month and a half, we've got models running on Kubeflow. So that's pretty, according to like the general consensus, this takes like 60 days to get something running on Kubeflow. So the integration was not that bad. All right, so you bet. Let's see if this is gonna work. Let's see. Oops. All right. Fingers crossed. It's running. All right. Bigger command. Perfect. So it's running now. So the problem was we needed to lead the output from the last run, and I forgot to re-download the data that was deleted. So that's why we had two failed runs. But anyways, so this is running. I'll show you the output of it because I've done it earlier today, and I'll come back to make sure that this actually was successful. But let's say over here, that's the different components. So when you see the different components, there are different artifacts, and the artifacts tells you a little bit of details about what are the components have in it. So over here it tells you, oh, it's saving this in this directory. So it has, and it tells you, okay, this is the vocabulary file if you want to have a look at it. But what's interesting is seeing that embedding dimension using TensorBoard. So we can open TensorBoard, and okay, it's not working. Let me just open it from the notebook. Perfect. So over here, what you're seeing is PCA for 128 dimension. So the idea of it is text with similar meaning or next to each other. So for example, if you use ILU or something, it will tell you the words that are similar to each other, how similar are they. You can visualize it. You can decide how many neighbors that you want to see. If you want to use Euclidean distance or cosine distance. So it's pretty interesting in understanding what is the meaning, and if there are spelling mistakes, that would catch it. Because it's retrained on it. So it will be actually very near in distance in that space from the actual word. I think I'm running over time, but just going back, we should have that test that we created finished. Yes, so it's done. So it takes around 2 minutes. You can do the same thing, and you can train it on any text data that you have. And you can visualize all your experiments over here and compare experiments. And I think that's all what I had for today. Any questions? I think that's the end of my presentation.
Before you ask more, I have a few more questions. Some of the people here use Python but don't use machine learning. So will you give a few more words about some of the tools that you showed them, just to give them an idea about what they are? Because Python is the machine learning language as far as I know today. People can argue, but it's pretty much out there. But can you please just give some definitions about, like, what's TensorFlow, what's TensorBoard? Some of the words you said mean not much to some people here.
Yeah, definitely. So what we're using most of the things is Python. So some things might be written in TensorFlow. After TensorFlow 2.0, most of the stuff are used in Keras now, which is a higher level API, which you use Python to use it. So Python would be, I don't know if I have something open, but in general, you would do all the pre-processing in Python. You would do the things you're just using the library Keras to do your machine learning aspect of it. So I don't know if that touches on your questions, but this is the general consensus is everything is in Python. Is just you're using things to be able to do pre-processing. You're using things to be able to do the machine learning aspect and then do the serving after that. But it's all in Python, which is the backbone of all of this. Yes.
So I'm pretty new to TensorFlow. I don't know a lot about it. How is it different from an Emr Spark cluster?
It's a different language. I'm not sure how to answer that. Okay, so Spark uses a lot of parallelization to do things. It serves the same purpose but in different way.
So is it a distributed master-slave configuration where you end up doing a lot of distributed map-reduce jobs in TensorFlow, or is it a machine learning model that is just running your Python script in a distributed fashion to make your enriched data more intelligent?
Yeah. So the main reason of TensorFlow is being very popular because it's working on tensors, and most of the machine learning aspects is matrix multiplications. So the main power of TensorFlow is being able to distribute the training and being able to do these matrix calculations very fast. So it's a little bit different idea from MapReduce. It's made specifically for having very efficient matrix multiplications and being able to, actually it supports XGBoost now, so they have XGBoost in TensorFlow 2.0. You can do stuff with it, but the main power of TensorFlow is having that fast computation of matrices. Yes.
I'd like to add a little bit to that. So to address your question, maybe she can add something. Yeah, go. Okay, sure.
Sorry. Cool. It's a good. So I wanted to add a little bit to that. So. TensorFlow helps you parallelize vector processing in the context of parallelizing on GPUs. So it doesn't help you in the context of parallelizing your job onto more virtual machines. So this is virtual machine. This is what we're looking at here is a set of virtual machines where each one of them has one or more GPUs. So there's multiple independent different layers of parallelization. You're parallelizing on top of the parallelization in at least 2 levels.
Yep. Thanks for writing that.
I have a very different question. I'm coming back to the model versioning that you touched on with this platform. with regards to schema versioning and model versioning, and say you've got 4 versions of your model in production with 4 distinct schemas, let's just say that's the situation. Does this help with that kind of situation?
Yeah, I actually can show you something of how it looks like. It's a little bit different. This is on AI platform, but it's the same concept. So let's say we have a model saved. Well, this doesn't have a lot of versions. So you have a model over here. Let's see. Anyway, so you would have the different versions. I can't find a model that has different versions right now, but yes, that's a good one. So you would have different versions that have different schemas. There also are metadata for what is these models are. There usually is a default one. So when you're calling, you're making the request for API. So this acts as a REST API. You're making the request. You define what is the model that you want and what is the version that you want. If you don't define the version, it will take the default version of what you're using. And that's kind of a way in getting to this versioning process. Does it address your question?
Yeah. This is a problem that's not well solved by a lot of platforms. So
yeah.
Thanks.
Thank you.
Someone really needs to ask a question? Because if not, we're going to take a break. Let's make it short, about 5 minutes. But first, let's please thank Muhammad Al Saeed.
Thank you.
Thank you.
I'll be around if anyone wants to chat. I would be more than happy to chat. But thank you so much.
Yeah, ask Muhammad questions. Oh, Danny.
Before you take a break, this is your monthly reminder. We need presenters. And this month, instead of reminding you that, I'm going to ask you, what would you like to see presented? Think about that and come talk to me afterwards. Give me suggestions for what we should be looking for. So, short break.
We have to remind them also next month is not you.
Good job, a little bit over time, but
good job. Look, it's hard. Give a tutorial in 30 minutes on how to start a click farm with a revenue chart. Okay. Yeah, that's what I want to see. A click farm. Where what I want to see is people set up multiple machines that are all sitting behind some sort of VPNs, so they obfuscate their locations and drive clicks through one of those stupid apps that pay you a tenth of a penny.
He creates a website, he puts 1,000 ads on it, and then he creates a click farm that will click on those ads, and every time he clicks, the advertiser will pay him.
That's what I want to see. I want to see that.
Okay.
That would be a cool thing to see.
Okay, that's kind of specific. I'm not
It
sure
is
if I
specific,
can find
yeah,
somebody to do
but
that, but
yeah.
okay. Do you want to do that?
I started on, but it's not ready to really.
Okay. All right, when it's ready.
Ask me in 4 months.
Okay.
Yeah.
Yeah, okay. You're doing a good job. I couldn't tell.
We have to remind you. We couldn't tell what.
That you have a
Okay. If it's okay with all of you, sorry for asking you to sit down again, but we do want to get started soon because we do have a limit of time.
Do you mind if I don't use the microphone?
I don't mind. I can actually see like this, but like it's better. I'm sure because the recording, I'm not sure it will catch. This is it's being recorded, so. Like this. Yes, it doesn't matter. Okay.
Hey, I'm going to go ahead and get started since we're close on time. Like to introduce myself. My name is Josh Bottom. Oh.
And Josh is from Ericto, and Ericto is sponsoring tonight. So let's thank Ericto first of all for sponsoring. So everyone, please. And Ericto actually means something. Josh, tell them what it means.
So Ericto means unbreakable in Greek. So if you're familiar with Kubernetes, also a Greek word, kind of fits in there. And our founders are both from Greece. So they're crazy because anybody that starts a company's got to be a little wacky, especially a tech company. Anyway, I have two roles. One is I'm a Kubeflow community product manager. The second is I'm a vice president at a company called Ericto, which we're based out of San Mateo, California, and we simplify Kubernetes storage. Hopefully, anybody here using Kubernetes? Okay, quite a few, thank you. So here's our agenda. We're gonna talk a little about Kubeflow, the community, a little bit about the user survey, do a demo, talk about data management, and then Kubeflow 1.0 and wrap up. So first, why are we here and why do we care, right? One of the first things that I've seen in what in this book, Scott Galloway talks about the four. These are the four companies that are really dramatically changing US and the world today. Amazon, Apple, Facebook, and Google, right? And the book has a lot of great statistics, a lot of good measurements. It talks about a lot about how machine learning is changing productivity, margin, market cap. It gives this statistic here about comparing General Motors to Facebook and the market cap per worker. And GM has a nice market cap per worker, 300,000, but Facebook is almost 40 times more. So what does that mean? It means that Facebook can get a lot more money to get better people, right? It means that they can invest a lot faster. And now we've seen these fast followers like LinkedIn and Spotify come to the Kubeflow community and start to participate in the community. And in fact, about a year ago, LinkedIn started in Kubeflow, and their goal and what they talked about when they came to the Kubeflow Summit, which we have at Google every 6 months, in March of 2019, their talk was how did they double the effectiveness of their ML engineers? So if there are ML engineers in the crowd here, you know how hard it is and how hard they work and how hard they are to find, but they're also very expensive. And then we had Spotify come in October, about 6 months later, and talk about how they were able to get 70% of their models into production within 12 weeks, right? Which is great. I mean, you're talking about getting models to market faster. And then back to General Motors. Back in 2016, GM bought a company called Cruise Automation. I don't know if anybody knows about Cruise Automation, right? For $1 billion. I was selling to these guys. They're out of the bay, right? Well, anyway, Cruise had a couple hundred people. Last year, Cruise was valued at $19 billion. I'm not talking million, I'm talking billions of dollars. And they have 2,000 people. To put it into perspective, General Motors has 180,000 people. And their valuation is $52 billion. There is nothing happening in I think, that you can invest your time in that will bring you back a return on your investment more than machine learning will. And if you look in the machine learning environment, there's a lot of projects out there, but the reason why I picked Kubeflow was one, it was based on Kubernetes, and two, it was primarily developed as a first way through with TensorFlow, both from Google, both one of the four. And if some people would say if software is the new oil, then ML software is the new gasoline, I would almost say it's even more refined than that. It's the new jet fuel. And what is Kubeflow here to do? It is here to make it easy for everyone to develop, deploy, and manage a portable, composable, distributed machine learning on Kubernetes. A lot of words there, right? Kubernetes, most efficient way to run basically applications out there today. Distributed, being able to run it across many machines of different types of machines. You need lots of GPUs or you need a lot of memory. You've got that composable. Today I might be using TensorFlow, but tomorrow PyTorch, maybe Keras, maybe Scikit-learn, maybe XGBoost. I need it to be flexible in terms of being able to use different types of frameworks, and portable, very critical. I start on my laptop. I need to move on-prem because I've got a lot of data, and then maybe I move to the cloud because I've got more access to more GPUs or other types of things. This is what Kubeflow is made to do. This is right from one of the two founders of the Kubeflow community, David Aronchek, used to work for Google's. Now he's over at Microsoft. This one you've probably seen a million times if you're doing machine learning, but the point of it is most people think it's all about the machine learning code, but it actually has a lot of DevOps involved in it. Right? So you have all this data collection, data verification, and feature validation. You've got to bring in your data, you've got to analyze your data, you've got to fill in the blanks, right? But then there's these things that are complicated, machine resource management. I've got all these different machines, I've got this big stack of software, and I've got to make sure that those machines are utilized effectively. Analysis tools, as you saw from Mohammed's presentation, he had a good analysis tool of his data. There are other analysis tools like hyperparameter in order to refine and make your models run faster. And process management tools. Once you have a workflow going, you want to put that into a workflow where it can be repeated quickly. Machine learning is about iteration. You're always going to be, your data is always changing, so you need to be able to run new data through your model, improve it, make those weights and biases better. And then serving infrastructure. Once you have your model trained, you may serve it on a different infrastructure. So you need a good way to be able to serve it, scale up, scale down, be able to do canaries, A/B testing, all that good stuff that you're going to do in serving, and of course monitoring as well. And this is what your workflow may look like: data ingestion, analysis, validation, transformation, all of your data. Split your data. Maybe you have to have training and a test set and then a validation set. Building a model, validation, training, serving, rolling, and then monitoring, logging. So this, again, is kind of a picture of where you're going to use and what's the kind of the general structure. You use Kubernetes as this ubiquitous layer to give you efficient operations and the most efficient way to utilize your hardware and your infrastructure underneath. And then you use Kubeflow to basically create an application that can be stamped out in these different environments to help make that operation of that application very consistent across the different environments that you want. So you simplify and speed the way that you can get to market. Kubeflow is a collection of several different types of sub-projects with software. So as Mohammed talked about, first you have your Jupyter Notebook. Think of that as your IDE, your training operators. These are basically the things that in your model that are going to set the weights and biases of your linear algebra equations, your workflow building. These simplify those process from once you have your model done, you want to be able to replicate it again. So in order to have a workflow, you need some tools. Kale and Faring do those two things. Pipelines. Once you have your workflow built, you want to run it in a pipeline. You have a couple different options: Kubeflow pipeline, TFX, Airflow. There are many others. But the idea here is that Kubeflow wants to give you flexibility. So you're not locked into any one of these tools. You want to be able to use the one that's good for you depending on the model or the application that you need to be able to do. Serving, again, you can think of KF serving as being the overarching program that has been developed by the community to bring in all the sub programs that have been underneath it. So you have TensorFlow serving, or you have PyTorch serving, and you have Audix, and you have some projects from NVIDIA, and you have Selden Core. What Kubeflow serving is gives you an overview of that allows you to use a single kind of format, a single programming abstract that's highly performant, so you don't have to learn 15 different ones. You have one that you get used to, and you can use these different machine learning formats in a serving. Metadata, you probably don't think, you think that machine learning is about your data and about your code, but there's a lot of metadata. There's a lot of other statistics. There's a lot of parameters and artifacts that have to be set up in order to make your machine learning work properly. And metadata is critical. And being able to manage your metadata will become more and more important as we go along. And then the tools. We talked about the hyperparameter tuning. How many people here have heard of the Kaggle projects, right? You can win $1 million by doing a particular contest better than anybody else. Well, this hyperparameter tuning tool called CATIB, which Johnny George and Richard Liu from Google and Johnny George from Cisco came up with, they basically ran one of the Kaggle models through this hyperparameter tuner one time, and they got a 20% improvement. So this is somebody who won $1 million. They took that model, they ran it through the hyperparameter tuner one time, and they improved that model by 20%. These are the types of improvements that you get from having Kubeflow. We'll go into more of them. And then data management. I think this goes to the ladies' questions before, right? Versioning, lineage, sharing between systems, users, and clusters, and different users in a secure way, very important. And reproducibility. We work with a lot of financial organizations, a lot of healthcare organizations, others that they need to be able to reproduce their models, and they can't just be done in a black box. We've moved Kubeflow along over the last 8 releases. Basically, we're going to come out with 1.0. It came, the release candidate was cut yesterday, and we'll go into a little bit more of that. But we've moved it from being the single applications to then connecting them and then adding in their metadata so they could share more information, and now productization and hardening. And so it's a really great community that's brought this together. And you can see the major organizations that are involved, right? AWS, IBM, Google. So you get to meet, Jeremy Levy or Abhishek Gupta, who lead the tech leads from Google, or some of the folks from AWS that are there, or from Intel, you might run into Cam, or from Selden, you'll get Lee Baker. Red Hat, you'll get Pete, and Microsoft, you can hook up with David Aronchek, right? And these people are very helpful and welcoming. And so from a community standpoint, one of the things is, machine learning is really hard. There's a huge stack. Everybody's learning. And so these people are very helpful. And what I like to point out on this is that even the end users like Bloomberg are leading in the KF serving delivery, or Gojex in the feature store delivery, and Intuit in Argo delivery. So, there are a lot of vendors involved, and you get a great interaction with them, but there's a lot of end users that contribute as well. And here's a couple of the people that do. I've mentioned a few of these before, but you can see double the effectiveness of their ML engineers at LinkedIn. Spotify, 7 times more experiments already. Our platform's been running in 2 years, and we have hundreds of data scientists running jobs daily. That's Bloomberg. Lyft, really big gains, automate the process of discovering the right hyperparameters, which used to take many days. Babylon Health, if you haven't seen them, they actually have done over 2 million consultations, primarily in Africa and other places, where they've automated the way that you get health diagnosis, but improve the feedback loop, which can enable so much more research. And then, Gojex, again, out of India, you may not have heard of these guys, but they're like ride-hailing on motorcycles. And then they've expanded that out. They've got 100 million users. Right? You get to meet so many interesting people, really change it, and this allows for so much more rapid experimentation, is what their quote was. So I'm going to move on from that, move in just quickly into the user survey. As one of the Kubeflow product managers, one of the things I came up with was, hey, we ought to listen to the users and take a survey of them, and then decide what we build from there. As a joke, no one laughed. But so we've been running these surveys about every 6 months, maybe a little bit more frequently. But you can see the majority of the people that answer are are machine learning engineers and data scientists, but there are DevOps, software, and data engineers. One thing I'd point out here is about 40% of the people are new, right? So we're very in tune that people that are coming in are new, and we'll try to be very welcoming. And to what Mohammed showed, right? 80% are using pipelines, 70% notebooks, 60% serving. And you can see some of the more advanced applications that are in Kubeflow: distributed training, feature store, hyperparameter tuning, metadata, all those things, visualization tools, all are on the list of either what people are using today or plan to use in the future. And then from a current usage standpoint, I find this to be very interesting. Most people on-prem, but that's where their data is, right? But you see all the major clouds being used. People are using GPUs, right? So again, you're moving into a lot of advanced applications that test you every day. And Istio usage, if folks, anybody using Istio in the room? You know, so service mesh for Kubernetes. So 70% either deployed or planned. And then the identity providers, GitHub and AD. And I thought that was kind of interesting. So we kept kind of studying a little bit more. And we saw that in the organization size, we had people that were over 5,000 people, and then we had organizations that had 51 to 500 people. And I kind of broke those up into what I called disruptors in enterprise, which may have been a little bit confrontational. But, you know, JP Morgan was there and US Bank, but we had a lot of disruptors in the room. So I was like, yeah, we have Nubank here. We have a lot of other guys. So anyway, the disruptors, 50 to 500, they were more on-premise and AWS. They used GitHub and kind of lighter on the security part and fewer of the components. But you can see over here on the enterprise, they were more LDAP and GCP, had security, air gap, whitelist, service mesh, much more of the advanced features on here. So that all makes sense. But it was interesting as a product manager, who do you serve, right? Because I get hundreds or thousands of issues that come in and I have to triage them and give them a priority. On this part, from a max user standpoint, what we were trying to figure out is how many users are there on a particular cluster. So we had users, notebooks, and pipelines. And what was interesting is people, and it makes sense, have more pipelines than they do notebooks than they have users. So one user can spin up several notebooks, but they'll have even more pipelines. So that makes sense. But what really got me was both the enterprise and the disruptor, 20% of them needed over 100 pipelines per cluster simultaneously. And then adoption blockers. And, you know, as a product manager or one of the guys working on this, it's kind of hard to see people talk bad, but look, you have to take the feedback, right? So deployment blockers, immature release date, documentation, lack of Kubeflow experience, single sign-on, security features, air gap. You can see on both sides, it's kind of interesting, the enterprise, which you may think would have more advanced people, they may have less than the disruptors, but it was just the opposite. So sometimes the data comes in and it's not exactly how you might think of it as it goes before. And areas of improvement, guess what? You needed more end-to-end tutorials, more word on Kubeflow, you know, other metadata, upgrading Kubeflow, fairing, and other troubleshooting. So I did a kind of a follow-up over the holiday. This was over Christmas, and you know what types of training that people are interested in. They wanted self-paced. They wanted data science workflows. They wanted hands-on code labs. They wanted some on Kubeflow operations. So that was kind of an interesting feedback from our group. And then, as I talked about before, you know, we get these mounds of GitHub issues that come in, and we have to prioritize them and send them out to people and ask them to work on it. But from deployment blocker, we really did work on our command line interface, which does the deployment where you build and apply. So that's called KF-Cuddle. And so we refactored that, made it closer to the way that Kubernetes kubectl works. And then on release maturity, we came out with definition of what it means to be a 1.0 stable application within Kubeflow, and we make people kind of take their applications through that. The documentations, we had 1.0 design doc, so it said the doc should look like this. And then we just finished up in Sunnyvale today, as well as around the world. There were several organizations involved. A doc sprint that we had everybody contribute. I think we got about 20 PRs done. So it was actually very successful over the last 3 days. And lack of understanding, we're doing end-to-end tutorials. I'll show you guys something very briefly here, and workshops, and then trying to work on all these other components down here at the bottom, you can see that we continue to work on Istio profiles and logging and other types of things to make those easier. One of the things that we want people to be able to do is have a workflow, have a what we call a customer user journey, a critical user journey. So in this one, which I'm going to show you, is first you're going to develop your application in the Jupyter Notebook. We're going to create a pipeline. We're going to run that pipeline, and then we're going to explore it. And we have some tools here, Kale and Rock, that we'll use. We'll use Kubeflow pipelines, and then Rock to do a little bit more exploration. So you can run this yourself. It takes about an hour and a half to do it. If anybody has a GCP account, you can get it up and running. It's not that hard. It's right in the marketplace, and it will run as a single image. Yes, go ahead. I will. Thank you. This is just a reason why you would want to be able to do this iteration, right? Why you want this ability. And this is from terrible picture that I took at the Kubeflow Summit last time, but I didn't get the slide, from Josh Baird at Spotify. And basically he said that 30% of his models still take more than 12 weeks. And really what it is about this iteration. And why is this iteration important? This is on this sample that you guys can all try. The number of workflow steps that we've changed now has gone from 24 steps down to 7. And when you estimate the time to have built this manually, you would have taken maybe 600 hours. Now it's down to 35 hours. If you did this by yourself without the tools, it's down from hundreds of hours down to tens of hours. And the roles that are required to build a custom model, right? You would have a data scientist, a data engineer, an ML engineer, and a DevOps, and they would have to come in and bring this Kubernetes, Docker, and what we call Kubeflow domain-specific language all together. Now that's all been simplified to where inside the notebook, the data scientists can build all this by themselves. So this is kind of the plan, is to make...
Can you repeat that? Do you need Kubernetes to know Kubernetes to use it now?
You don't need to know Kubernetes. And we've had over 7,000 people use that example that I've shown you in less than 9 months since we introduced it. So, I mean, people are flowing in at an increasing rate. It's not, the hundreds of thousands that are into Kubernetes yet, but you're seeing more and more people come this way. In this tutorial, we'll talk about which is the Titanic Kegel example. If you're familiar with this example, it's who will survive the Titanic shipwreck. So you have a data set, and what this will do will predict who will survive. You've got some code and some data. You'll use Rock and Kale to protect your work product. So you're going to take a version snapshot of that, and then you'll convert from your notebook to a pipeline, and then run that pipeline, review the results. Then you can re-examine your data set and your code, because this is part of that iteration process, and then fix some data, rerun the pipeline, and review the new results. We're not going to go through all of that, but this is what you can do in about an hour and a half working in this. So we'll jump over here and we'll see if we can actually have a live demo work. All right. Let me get to first a very quick overview. You guys saw this. This is the Kubeflow landing page, central dashboard. Probably can't see this, so I'm going to blow it up a little bit and hopefully not give you guys a headache. So over here, when you have your home, your pipelines, your notebook server, CatTib is your hyperparameter tuner. So pipeline is your workflow manager. Notebook is your IDE. CatTib is your hyperparameter tuner. These are all the parameters that your model won't set, that you have to set. Your artifact store, this is where you keep everything that's outside of your data set, all the artifacts so you can recreate your model. And your snapshot store, your managed contributor. And then you have these quick shortcuts to your notebooks, to your pipelines, your documentation, and elsewhere. So I'm going to go from there right into notebooks. You can see your notebooks here. Does everybody know how to, go ahead?
Is this a GCP only project?
No, the whole idea is that this is designed to run portable. So Kubeflow runs on AWS, on your laptop, and on all the major clouds, right? But this particular tutorial runs on your laptop on Vagrant or in GCP in MiniKF. But we first came out with it on MiniKF on GCP. It's a single node cluster of Kubeflow that spins up in about 15 minutes, right? So you can get up, get running, get experience with it, get your hands on and not worry about all those low-level details. Get your hands on with the actual tutorial, right? That's the view. Hopefully I answered your question. So anyway, one of the first things that you'll do when you're in this is to go ahead and set up a new notebook, and you can give it a name, and then you can pick your image, right? You can pick what size image you want, GPUs or not, what your CPU and your RAM is, what your workspace, and then data volume. This is something that we added because Kubeflow was set up as separate software projects. It wasn't really designed to share data between each other. And so sharing data required a lot of work. That's where those hundreds of hours come in. We've simplified that by using persistent volumes. And so adding this volume here gives you a persistent volume that you can share data between users, between different systems. And then you would come down here and you can hit launch. And I've already done that. Let's see if I can get this to come up, and it shows it. So what we're going to do, I'm going to go to the answer first and then come back and show you this. Hopefully this will come up. This is the graph that we're going to talk about, that we're going to build. Maybe you guys can see this. Do I need to blow it up a little bit? So first you have this graph, which if I shrank it, you'd see it a little bit better, but has two data volumes that we're going to pull data from. And this graph is showing the data flow more than the sequential actions of the actual program, because it's very important to know how your data is flowing when you're trying to debug. Anyway, the first thing we're going to do is we're going to load data. Then we're going to do some data pre-processing, right? We're going to do some feature engineering. Then we're going to run several different types of machine learning models and then look at the results from those models, pick the best one, and at the end we'll take another snapshot. So how do we do that? Let's go back to our Jupyter notebook. So in the Jupyter notebook, I'm going to give you a headache here. I'm moving very quickly back up. You can see this doesn't look like a normal Jupyter notebook, right? And what's different about it is that I've turned on this open source project called Kale. And what Kale allows you to do is label these cells with a label. And that label then becomes part of that notebook that we just saw. And it helps to automate the building of that notebook that we just saw. So this imports is a special one. This is where you're going to import all your libraries, right? And then you're going to go into your load data. So this is bringing in your data and be able to load it. Now in your notebook, you could have a lot of steps that you don't want in to reproduce, but you're just experimenting. So you would skip those steps. So you have this one, it says skip and skip. Maybe you guys can't see that. But then you'll come down here and let me see if I can find the next step is data preprocessing. So we get to data preprocessing, and that's dependent upon the load data step before it. Now this will make more sense when we go back to and look at the graph probably, hopefully. And we'll keep going, and you go from data preprocessing to feature engineering, which was one of those steps we saw on the graph. And then we go into the machine learning, and you can actually run these in parallel. You can see that I could run random forest logistic regression in my base, all in parallel, not having to wait and do those sequentially. So now, what do I want to be able to do? I've got my work product, I've got my results, I think I like them. So now I want to compile and run. I hit this button here, hopefully with some magic. First thing I'm going to do is I'm going to take a snapshot. So now I have a version of both my code and my data set, right? And then what it's going to do is it's going to take this pipeline and containerize it. It's going to take each of these steps, put them into a Docker container, containerize it, and then make code to connect all those steps to run appropriately. Go ahead.
Is this Kubeflow pipeline?
Yes. Yes, it builds a Kubeflow pipeline. Sorry if I wasn't clear. And then it actually uploads that pipeline, and we can see, hopefully, this Kubeflow pipeline being built before our eyes. So you can see these steps as they're sequentially being run, and this graph will fill in over the next few minutes. And so the plan here basically is, before, when I got done with my notebook, I had to go to an ML engineer, or I had to go to somebody else to say, okay, can you break these up, all these cells, and put them into a Docker container, and then write some code to make them run appropriately. Oh, and by the way, I also need all the data to flow. That is all the things that we have now automated into this, which is going on. So this is very important in terms of a productivity improvement. So I've already run this before, and we did this, and we've got these results that came out, and we look at the results, and we go, oh, darn, we're not that smart, because all of my models came out with 100% accuracy, which we know can't be right. So we said, you know what? We need to do some more analysis. So I can go back into one of these ML models, and I can say, you know what? I'd really like to look at what the model looked like at that particular point. And so I can go in that model building that we did, we took a snapshot of this particular step right at the time that it was being built. And we can click on this right here, this snapshot, and it will take us to another piece here. Let me see if I've got it. Anyway, another system, which is called Rock. I'll go ahead and do that now. And that will bring up basically my workspace and my data set right here, which now I can use this right here to build a new notebook and do more experimentation. And I've built that notebook already. And I can go in and I can look at my notebook and I can say, oh man, I think I figured out what my problem was. I left the survived column in my data set, right? So now if I take that out, which I ran this train df drop survived out of here, right now I don't have the survived, the answer in my data set. And you can see that my random forest went down from having 100% down to 92 because I printed out the results. Now I compiled and reran the results, right? And I've got results here, and I can go and look and I can see that now my results, instead of being 100% for all of these, it went down to 92% and even lower for Bayes and some of the other ones. So I can say, hey, random forest and decision tree are the right models for me to spend time on. Are we almost out of time? So anyway, that's it for the demo. I'm going to jump back and finish up. Hopefully that was helpful. I don't know if hopefully you guys got something out of that. And let me go back here real quick just to finish up, and then we'll be done. So one of the things that makes this all possible is the ability to do those snapshots that we talked about. And one of the things that's real important is the ability to keep the snapshots and take lots of them. And Kubernetes is immature. So its snapshotting is not like what you get from VMware and other things. It actually, the snapshotting, it comes around and it slows down the critical path. But what's been developed is what's called true secondary storage. And we've implemented that in our products, which have just been released, patented, with durability and portability using Kubernetes primitives. So what does that mean? We've been able to use what's called a Kubernetes daemon set or a sidecar. And through the Kubernetes storage interface, we present a storage class to the Kubernetes CSI. And that storage class allows us to support things like dynamic volume provisioning and through persistent and persistent volume claims. I could spend an hour on that discussion, but basically it allows us to snapshot from a local disk, which is much faster than running off some type of network storage, right? Which is right on the node itself. You run your data and all your training off a local disk, and you snapshot onto Object Store. So what does this do? It's faster, it's cheaper, and it gives you more replication, right? It gives you more repeatability. Kubeflow, just to sum it up, 1.0, we've got a roadmap. We publish it. We have a versioning policy. We have stable, beta, and alpha designations for all the applications. We have an applications requirement. It says these are the guidelines that you have to fill in if you want to take notebooks or pipelines or any of these things and call them stable. And then we have a Kanban board that tracks everything. And here are all the stable components in Kubeflow, and here are the beta components that are in Kubeflow. And so just to kind of finish up, I was at KubeCon in November and presented with US Bank and JP Morgan. Here are some of the statements that they made for our Kubeflow release back at that time. Multi-user functionality is a basic building block, especially for on-prem, and data versioning, especially for Kubeflow pipelines, allows us to snapshot data sets and recreate models quickly. That's from Laura Schoenack from JP Morgan. And then from the disruptor side, you can see Jeremy Valley talk about how hyperparameter tuning, especially with the new suggestion CR, helps them quite a bit. And Tim from Descartes Labs talks about how moving basically from different types of models helps their productivity a lot. So here's what I would say to you. Again, I'm passionate about Kubeflow. I think it's a great project. It's very welcoming. We're improving the productivity of people. But more importantly, I think from a machine learning revolution standpoint, we are at the forefront of what's going on. You can come and join. We have meetings every Tuesday. They're open to the public. We also have these semi-annual meetings at Google in Sunnyvale. You'll meet a lot of great people. You'll learn a lot of things that other people are doing, share stories, and some of the best and brightest in our industry. So with that, I welcome you to join us, and thanks for your time.
We don't have time. Maybe one quick question, but before that, a few announcements. Next meetup, Python meetup, is not here in Capital Factory. It will be in Rackspace up north. So check out, and this is the monthly Python meetup. Before this, we have the evening of Python coding, and of course, Tipton's meetups. One quick question, and then afterwards we need to leave.
Just wondering how you have the data. So in your notebook there, you made these little boxes, but then you said that data went from one to the next. So what does that mean? It goes from one to the next. Do you like wrap it in a JSON? Does it get put in a database, or?
It's in a persistent volume, and it's able. Well, it depends on where you're looking at the actual data flow inside of the notebooks. The pipelines itself. Is that the question?
Yeah, if I just have a variable up top and it's a data frame or something, right? And then I move down to the next one, and I'm going to use that data frame. How does that get moved for me? Does it just automatically happen? Like that yellow box to the purple box, right? If I want to use a data frame in the yellow one, and then I want to use the same data frame in the purple one, do I have to do something to do that, or is that like automatically?
Yeah, that's not in the scope of the solutions that I was talking about, but that's more in just standard Jupyter Notebook functionality.
Okay. Okay.
And Python, right?
Because like I usually just treat this as like one Python file, and I don't have to like, usually like redefine a data frame over and over and over. But now if you're separating this all out, now I have to like repopulate my data frames, redo all this work over and over and over again.
Yeah.
Let me get a specialist to answer that question, but I don't think it's as complex as what you're saying. We'll follow up offline on that one.
Okay, sorry, but sorry if we have to cut down, but we do have to leave this. Again, remember, next monthly Python meetup in Rackspace, and everyone who's want to talk more, we're going to the Russia House. It's on 5th Street. You're welcome to join us. Some of us will be there. We can talk more and maybe answer some more of your questions. Thank you.